So we have seen how to find the root of an equation by using bisection method and by using the false position method. False position method is also called the regular falsy method. Now in this video we are going to look at how to find the root of an equation by using Newton-Raphson method, and we will try to understand this through this question. So the question is, find the root of an equation x cube minus 3x square plus 7x minus 8 equal to 0, correct to one decimal place. So for the first step we will write what is f of x. So in this equation, whatever is on another side of 0, that is f of x. So it is x cube minus 3x square plus 7x minus 8. Since we have to find the root correct to one decimal place, so our goal here is to find a number c such that when we plug it in the function, we get after the decimal 1 0 correct to one decimal place, and the second could be any digit. So it means that we are going to fix our calculator up to 2 decimal places. Okay, after fixing the calculator up to 2 decimal places, we will get back to our question, which is find the root of the equation x cube minus 3x square plus 7x minus 8 equal to 0. Here we are calling f of x as x cube minus 3x square plus 7x minus 8. Just like in bisection method and false position method, the step 1 here is the same, that we have to find the interval in which the root will lie. To find the interval, we'll start with finding f of 0, which is minus 8, which is less than 0. Then we find f of 1. You plug 1 in the function in the place of x, and you will see that for 1 you get minus 3, which is also less than 0. Next we find f of 2, which is 2, which is positive. So we know that once we have opposite sign values on two numbers, that's when we have the interval. So interval will be composed of these two numbers, 1 and 2. So the interval is 1 2. It is an appropriate interval because on 1 the value of the function is negative and on 2 the value of the function is positive. And we are going to call this interval as AB, which tells us that A is 1 and B is 2. So the first step was to find the interval. Now in the second step, we will find the successive x values, and one of those values will be the root of the equation that we are trying to find. So to start with step 2, we will write the iteration formula for Newton-Raphson method, which is xn plus 1 is equal to xn minus f of xn over f dash xn, and dash here represents the derivative, and n here is running from 0 1 2 3 and it goes on. Let's call this formula as 1. Now let's say if we have n equal to 0, in 1 we get x1 equal to x naught minus f of x naught over f dash x naught. It means that to start the Newton-Raphson method, we need the initial x value, which is x naught. So first we have to find x naught. So in the previous video, I derived this formula for Newton-Raphson method. There I talked about how to find this initial point x naught in the Newton-Raphson formula. This x naught is either a or b. So x naught is either 1 or it is 2. Now the condition to find x naught is that if f of a absolute is less than f of b absolute, then you will call this a as x naught. Or if f of b absolute is less than f of a absolute, then you will call this b as x naught. Now let's look at what we have got. So we are calling a as 1 and b as 2. And f of 1 is -3 and f of 2 is 2. So we have f of 2 absolute and f of 1 absolute. F of 2 is 2 and f of 1 is -3. But when we take the absolute, we have 2 which is less than absolute -3 is 3. So we will replicate this sign. So now look at this inequality. F of 2 absolute is less than f of 1 absolute. So we are going to call this 2 as x naught. Let's try to understand this through example. Let's say you have f of 5 as -6 and f of 20 as 7. So f of 5 is being compared with f of 20. But we will have to take absolute on both. F of 5 absolute is 6 and f of 20 absolute is 7. We know that 6 is less than 7. So here we will replicate the same inequality. From this side, since this f of 5 absolute is less than f of 20 absolute, so we will call x naught as 5. Back to our question. In our question, the initial value is 2. That is what we needed to plug in this equation. X1 equal to x naught minus f of x naught over f dash x naught. So we have x1 is equal to x naught, which is 2, minus f of x naught, which is 2, whole divided by f dash at x naught, which is 2. Now for this we need the derivative of the function. So we have f of x equal to x cube minus 3x square plus 7x minus 8. So we will find f dash x. The derivative of x cube is 3x square minus 6x plus 7. So by using the power rule, we got the derivative of function f of x as f dash x, which is 3x square minus 6x plus 7. So now we will plug in the values for x1, 2 minus f of 2 in the beginning. So b is 2 and f of 2 is here. So f of 2 is 2. We'll plug it in here. 2 divided by, we have to find f dash at 2. So 3 into 2 whole square minus 6 into 2 plus 7. So f dash at 2, after some calculations, we will see that it is 7. Let's plug this value in here. So x1 we got as use the calculator and you get x1 as 1.71. So in bisection method and false position method, we were picking the right intervals, and somewhere in those intervals there was the root. But here in Newton-Raphson method, we don't have to find the interval. We keep on finding the successive x values. Now we find x1. So every time you find a new x, you plug it in the function like this, f of x1, which is f of 1.71. We have the function, this is the function f of x. We plug it in here, 1.71 in the place of x, and we get for f of 1.71 as 0.20. Now the question is, should we stop here? Did we find the root? No, our goal is to find some number c such that it gives us 0.10 after the decimal and some digit. So we have 0.20, but we need the 0 on the right of decimal. So we will continue to find the next x value, and the next x value will be obtained by putting n equal to 1, because in the previous step when we put n equal to 0 in 1, we got x1. Now we are going to put n equal to 1 in the formula 1. When we do that, by putting n equal to 1 in the formula 1, we get x2 equal to x1 minus f of x1 over f dash x1. x1 here is 1.71 minus f of 1.71 divided by f dash 1.71. 1.71. What is f of 1.71? We have it in here, which is 0.20. But to find f dash 1.71, we have calculated f dash x in here. So we will put 1.71 in the place of x. 3 into 1.71 square minus 6 into 1.71 plus 7. This gives us f dash 1.71. It is 5.51. So let's plug it in here, 5.51. We find the value of x2, which is 1.67. Every time we find an x, we plug it in the function to see that if we got the right number of zeros on the right of the decimal. So we calculate f of 1.67. We have the function as x cube minus 3x squared plus 7x minus 8, and in the places of x we put 1.67, and we have 1.67 cube minus 3 into 1.67 plus 7 into 1.67 minus 8. And when we do this computation, we get f of 1.67 as minus 0.02. Please know that minus 0 is same as 0. So our goal was to find some number c which gives us almost 0, that is 0.010 on the right of the decimal and some digit. So here we got something like that. We have minus 0, which is 0. So after the decimal, we have 1 0 and our digit. That's what we were looking for. So we will say that 1.67 is the root of the equation x cube minus 3x square plus 7x minus 8 equal to 0, correct to one decimal place. Or we can round up 1.67 and write it as 1.7 and say that 1.7 is the root of the equation x cube minus 3x square plus 7x minus 8 equal to 0, correct to one decimal place. So this is how we find the root by using the Newton-Raphson method. We have seen how to find the root of an equation by using false position method and bisection method. In the next video, we are going to look at how to find the root of an equation by using the secant method.